Hello class and welcome to week 5, day 2 expectations and close reading. Today we're going to be going over the expectations and then diving into the close reading like we usually do. If you don't need me for the close reading, you can stop watching after that, but let's dive into the expectations. So the very first thing I want you to do is a close reading on pages 5 through 9 of the PDF. Again, this is highlighting, underlining at least one thing that's important in a paragraph, and then commenting or writing a question for each thing. This should feel like an academic task. It should feel like you're doing something and engaging with the material. It's not just simply to read for information, but also show that you can do something with that information. After that, I want you to answer the question 1 on page 8 of the PDF. So that's looking at being able to describe the process of digestion, starting from your mouth and traveling down through your body all the way to the rectum. I want you guys to answer that in a complete question or a complete sentence, and make sure that we're working on our writing skills. After that, look at page 9 of the PDF and answer this question, question number 2. What does the urinary system do that is different from the digestive system? So I want you to be able to compare and contrast the digestive system with the urinary system and be able to define what the urinary system does. Again, all in complete sentences. I want to make sure that you guys are able to be good writers going into 8th grade, so you guys can be good writers going into high school. After that, I want you to complete any math homework from Miss Moore, review and practice movements from mystery class, and then again, I want to make sure that you guys are moving. This should just say moving. You guys can use these activities if you want, but just make sure that you're going on a walk with your family, running, riding your bike. I know some students have been doing some games with their families. Just make sure that you're moving around. Alright, let's dive into the close reading. Starting on page 5. The digestive system. When you have finished this lesson, you will be able to identify and describe the major parts of the human digestive system and their functions in the body. You will recall from lesson 26 that digestion is the process by which foods are changed into forms that can be used by the body. During digestion, the food that you eat is broken down into smaller pieces. The original Latin word means to cut up. More complex chemicals in food are changed into simpler ones that can be used by your body. The organs that digest food make up your digestive system. I can't talk this morning. Digestion begins in the mouth. The jaw, teeth, and tongue work together to cut and crush food into smaller pieces. Saliva is a liquid in the mouth that mixes with the food. Saliva contains chemicals called enzymes. These are protein molecules that start to break down the complex carbohydrates in food into simpler ones as soon as you start to chew something. Saliva helps to change the starches in foods into simple sugars that are easier to digest. Salivary glands in the mouth create and release the saliva in your mouth. Sometimes just the thought of food is enough to activate these glands and make you salivate. Saliva does 2 other important things. This is an important diagram. Saliva does 2 other important things. It moistens food and makes it soft and slippery so that it can be swallowed. Saliva also helps to keep your mouth clean by washing away any tiny food particles that may be stuck between your teeth. After food is chewed and mixed with saliva, it is swallowed into a sturdy but flexible tube called the esophagus. The esophagus connects the mouth and the stomach. The muscles of the esophagus contract in a wave-like squeezing motion that pushes food down to the stomach. The movement of food by the special muscles throughout the digestive tract is called peristalsis. You've probably noticed that some things are easier to swallow than others. That's because peristalsis works great on soft, wet globs of food, but if you hurry, are nervous, and don't chew well, or are taking supplements or medicine, sometimes it can get stuck in your throat. It is important to chew your food well to avoid choking. Food is pushed into the stomach, but not before knocking and opening a little door. Well, not exactly, but there is a valve. Valves are important structures found in all kinds of organ systems in the body. Here, in the digestive system, valves open and shut to keep food headed in the right direction, and to keep digestive juices where they belong. Stomach fluids would hurt the esophagus if they splashed into it, which is why the valve stays tightly closed. When it doesn't, people call this painful feeling heartburn, but it doesn't have anything to do with your heart. The walls of the stomach are made of strong muscles that tighten and squeeze the food, mixing it with more digestive juices and enzymes. A strong coating of mucus constantly recoats the convoluted and expandable walls of the stomach so they aren't hurt by our sour contents. by its sour contents. The food has, by this time, turned into a thin, creamy mixture from which the enzymes are releasing the nutrients into the food. These nutrients will be absorbed later in the small intestine. The partially digested food moves from the stomach in little spurts into the small intestine. The 12 to 25 foot long small intestine is lined with thin cell membranes that allow most nutrients to pass through and enter the bloodstream. The inside of the small intestine is like a rumpled shag rug. Tiny finger-like projections called villi are each coated with hair-like microvilli. These encourage molecules to linger near the villi long enough for those molecules to be absorbed in the bloodstream. Not all the food you eat enters the bloodstream as nutrients. Undigested food travels on into the large intestine, which is also called the colon, where water is reclaimed for the body. This is very important because we need water more than anything. The large intestine is only about 3 to 5 feet long, but it is wide compared to the small intestine. As the water is removed, the more fibrous parts remain, along with molecules too big to have been broken down by our system. This food is not wasted though. Billions of harmless bacteria live in our large intestine, and they digest for themselves some of what we can't. Gradually, as water is reabsorbed, solid feces are formed as our former meal nears the end of its time with us. The feces then enters the rectum. The rectum is a muscular part of the intestine which also uses peristalsis to contract and push the waste out of the body through the anus. Other organs important in digestion. The stomach and intestines would be ineffective without several other organs. Most of these, like the pancreas and gallbladder, are glands that produce and store enzymes and hormones which contribute to the functioning of the system. In addition to cells needing nutrients, they also produce waste. For removal of waste from the blood, we count on our kidneys and liver. We have learned that enzymes are chemicals that help to digest food on the molecular level. Enzymes are produced in all but the final stages of the digestive tract. Each kind of enzyme is geared to only one kind of food. The enzyme in saliva only digests starch. The enzymes found in gastric juice produced by the stomach are pepsin and renin. Gastric juices also contains water and hydrochloric acid. Both hydrochloric acid and pepsin digest protein, which means they can break protein down into amino acids in the stomach. Digestive juices in the small intestine also contain many different enzymes. One of these enzymes is lipase. Lipase digests fats and oils in the small intestine. The pancreas and liver add their enzymes to the action here. Since the main job of the small intestine is absorbing nutrients, it is not coated with protective mucus like the stomach before it. In goes all the acid-stomach mixture. From the pancreas produce bicarbonate, like baking soda, to neutralize the acid mixture. The liver is the largest and most complex organ in our bodies. It is a remarkable chemical factory. The liver is not directly connected to the digestive tract. It has many important functions, including the essential job of converting nutrients to glucose. If additional glucose is not needed, the liver stores materials for making glucose until it is needed. The liver keeps close track of when organs, especially the brain, need glucose. The liver can also make many other chemical molecules that the body, not just the digestive system, needs. It filters poisons from the blood that the kidney doesn't. It stores vitamins, minerals, and fat until needed, and it digests harmful molecules like alcohol. The liver works hard. We'd be in trouble without it. Back to the digestive system of food. Bile is green and foul-smelling, but you rarely have to see or smell it. The liver secretes bile into the gallbladder, a small sac tucked under it. The gallbladder drips bile in the small intestine where fats and oils have clumped up. Bile breaks this fat down into tiny droplets. Although bile is not an enzyme, it does cause change to take place. This breaking up of fats is called emulsification. The small intestine needs a uniform, emulsified, and warm slush of food, and enzymes and bile make sure that happens. Describe the process of digestion, starting with your mouth and traveling down through your body all the way through the rectum. Again, I want complete sentences for this. We each have 2 kidneys. Our kidneys are located just above our waist, on each side of our backbone. The kidneys filter blood, cleaning out waste that cells produce. They help the body get rid of liquid waste and are not connected physically to digestion. Urine is the liquid waste formed in the kidneys and then collected in the bladder. Although urine is mostly water, it also contains salts and urea. Urea is what the liver makes when it breaks down old, worn out proteins that cells have tossed out into the blood. The kidneys are so important that a full quarter of your blood is being filtered through them at any time. Wow. The kidneys and bladder, and the liver, and some of its functions, together form the urinary system. As digestive system happens, nutrients, micronutrients, water, and toxins, along the other components of food, enter our blood to be transported to the cells of the body. The parts of the food that we need, such as the nutrients, are then used by the body cells for energy, growth, and repair. Carbohydrates produce heat energy and muscle energy. Proteins are used to build and repair body cells. Fats are stored and used to supply energy when needed. Vitamins and minerals help keep the body healthy. On the other hand, components of food that are harmful to our cells can also be absorbed into our blood during digestion. If we have eaten plenty of fiber, some of these toxins don't get a chance to be absorbed, and they leave the body with the fiber. You may recall this from lesson 27. Usually some toxins do get absorbed into our bloodstreams, but if our liver and kidneys are healthy, they help us by clearing toxins out before they have a chance to hurt our cells. When we make educated choices to eat healthy foods, we help our bodies to be healthy and strong. All right. That was a rough reading. I don't know what's wrong with my talking this morning, but thank you guys for checking out that video. Here we have the urinary system diagram. Here we have liver. Here we have the stomach, upper portion, lower portion. And here we have the full digestive system. One of the activities that I want you guys to do is to compare and contrast the urinary system and the digestive system. How are they different? What do they do? So please look back through this close reading. It should take a little bit of time to be able to answer that question. All right, that is everything for today. I hope you guys are doing well. I miss you guys a lot and can't wait for things to get back to normal. Bye.